Okay, it's Monday, November 3rd. First day of the new 9 weeks. And this was actually kind of a good place to wrap up. If we see here on the weekly notes, everything we were doing on Friday on page 217, you should have wrapped up. And now we're going to talk about naming and writing chemical formulas, which we're going to use every day. And it's a good breaking point. That needs turned in today. Should have done by now. It's not exciting stuff, but seriously, you should have that done. And I reworked the flip chart, so we're starting at a fresh spot. Okay, so there is a better way to set up and organize how to name and write these chemical formulas than how it's presented in this book series. And that is, on the end of this paper, there's covalent compounds, which we're not talking about today, but then the other ones are broken down into 4 sections, and that works for most things. And ammonium is a little sloppy trying to work with that, but other than mostly ammonium, these 4 groupings work best. So we've probably already filled out binary representative metal. So you have those transition metals there in the D block, and you should know what I'm talking about with that. And I'm not going to show you the periodic table. You should know. If you don't, look it up. Representative is alkali metals, alkaline earth metals, skipping the transition metals, then boron family, carbon family, nitrogen family, oxygen family, halogens. And we don't have to worry about the noble gases. They don't make compounds. So we're not going to be talking about them for a while. So those 7 groups or families. Transition metals will come into play. Their naming is a little bit different because you have to know about oxidation numbers. And the book doesn't even do oxidation numbers in this chapter. We're going to skip ahead and take a look at that. So you probably have these ones named already at the top. We did all this last year, so you should be at least familiar with it. So binary compounds have 2 elements. One from the left of the periodic table and one from the right is what we're talking about right now. So we're going to start again and practice a few, and then we'll throw in polyatomic ions. Their naming and formulas are a little different. Okay, so let's just try a few here. Try naming this one, and this one. Pause your device. Try them and we'll check it. So pause. Okay, if you wrote the names for those, C-A-S-K-E-S-E-A-L-T-E, and then with these ones here, you tried writing the formulas, BAO, CABR, MGP. You had to count electrons with your fingers and then come up with the formulas. So calcium gives 2, sulfur takes 2, that's a match at CAS. Potassium gives 1, selenium's below sulfur, it takes 2, that's not a match, so I need 2 potassiums. Aluminum gives 3 electrons, valence electrons. Tellurium takes 2, it's below sulfur also, it's below selenium. Not a match. I need to move 6 electrons. I need 3 telluriums and 2 aluminums to do that. You can switch the numbers. On the naming, it's going to be BAO, CABR, MGP. But then you got to manipulate the numbers. So pause that and try it. Okay, and if you've tried it and come back up, it's BAO, CABR2, and MG3P2. Because BA gives 2 electrons, valence electrons. Oxygen takes 2 valence electrons, that's a match. Calcium gives 2 valence electrons. Bromine takes 1 valence electron, that's not a match. I need another bromine. Magnesium gives 2 electrons. Phosphorus is below nitrogen, it takes 3 valence electrons. Not a match. Got to move 6 electrons, so I need 3 magnesium, 2 phosphorus, to move 6, or switch the numbers works. So this is a restatement of this diagram. So we have binary representative metal, binary transition metal, polyatomic ion with representative metal, polyatomic ion with transition metal, and then covalent compounds. So there's 4 different ways to name ionic compounds, and then we'll name covalent compounds too, and there's 2 ways to do that. So this is what we started with, and then we'll move into the others. Okay, so from the top of the paper, you may already have this done, the paper that looks like this. The names and chemical formulas. Pause here if you don't have them done, work them, and then come back and check. And this is what you should have. Calcium gives 2, so it needs 2 chlorine. Calcium chloride. Notice 2 names. First name second name ends in ide. Calcium chloride. Lithium oxide. Magnesium nitride. Aluminum sulfide. And from the names you have, always write the letters in and then change the numbers. So sodium is Na, chloride is Cl. Potassium is K, fluoride is F. Beryllium is Be, phosphide is phosphorus 2, or phosphorus, P. Aluminum is Al, oxide is O. Then try the numbers. Sodium gives 1, chlorine takes 1, that's a match, it's NaCl. Potassium gives 1, fluorine takes 1, that's a match, it's Kf. Beryllium gives 2 valence electrons away. Phosphorus takes 3 valence electrons, that's not a match. I need 3 beryllium and 2 phosphorus. Aluminum gives 3 valence electrons away, it's below boron. Oxygen takes 2 valence electrons, this is not a match. I need to move 6 valence electrons. Aluminum is supposed to be 2, and oxygen 3 to move 6 valence electrons. Probably already had this done. Then, the set below that, you have transition metals. These are in the D block. They can have different numbers of electrons they give or take. So we have to tell you what they are, or you have to figure them out. Okay, so first of all, naming this is copper chloride, but you have to give a valence number. I have a chlorine and a copper. They match. They each give, since they match, they each have, copper's giving 1 valence electron, chlorine is taking 1. Because of that, we know that's copper 1 chloride. Iron and oxygen. Oxygen takes 2, there's 3 of them. 2 times 3 is 6. I have 2 irons giving me 6, they've got to be 3 positive apiece. It's got to be Fe iron 3 oxide. Sulfur takes 2, we know that. Iron's got to be given 2 because it's a match. So this is iron 2 sulfide. Cobalt chloride, well, the chlorine takes 1, there's 2 of them, cobalt's got to be 2. Pause here, make sure you have those filled out over here. And this is what you have. Copper gives 2. We know that. It tells us that chlorine takes 1. Not a match. I have to have another chlorine. Iron gives 2. It's telling us that. Oxygen takes 2. That's a match. FeO. Nickel gives 3. It's telling us this. Nitrogen takes 3. That's a match. So it's NiN. Nickel gives 2 valence electrons away. Oxygen takes 2 valence electrons. That's a match. So it's NiO. If you have a question about one of those, make sure you ask me when you get, first time you get a chance. Okay. Now, your polyatomic ions you're supposed to know from the flip charts. Now you can forget about the ides. Everything in the binary, all of these were binary. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. They're all binary. They all ended in "ide." With polyatomic ions, you have ammoniums and phosphates and carbonates and chlorates and sulfates. They're no longer ides. But it still has two names. So you're supposed to know the name from the little flashcard you have, and then that's just what it is. You just write it down. So try naming those. We're going to pause it on this video and probably come up with another video. And by the way, while you're at number 3, this is the last section here. Go ahead and give the 4th section, because all you're doing is a transition with a polyatomic, so it's not a new skill. You're just rearranging them in a different way. So try to fill those out and we'll check them.